I would like to thank you for the opportunity to present to you my sample lesson today. I'm going to try to keep this as brief as possible. I'm going to explain some things in the very beginning, go into the I do part of my teaching, where normally I would ask students for input as we go along, but I know that lengthens a little bit of it. And then at the end, I'll share how I would continue the lesson past the I do part of it when we get into the we do and the you do parts as well. All right, so when I start my class, I start with a meeting chat poll, a do first, and a reminder to please turn on your video. There are three reasons for this. The first one is a social, emotional, kind of formative check of like where they at, and where they are that day. And sometimes they're silly, sometimes they're very straightforward, sometimes they're a little more obtuse. Like this is just kind of see like, where are kids really? Because not everyone looks forward to the weekend because they're not going to have the ability to get food or see their friends. The middle part is so that they are constantly reinforcing skills that we have previously learned and also looking at test taking skills since most of the classes that I teach are juniors and they're taking SAT and ACT as they prep for college. So I focus on those skills that I gather from various websites and resources. And then the encouragement to turn on their cameras and to greet me at the beginning of class is just a reminder that I want to see who they are, get to know them face to face, because nothing replaces, even in a virtual setting, that ability to make eye contact and to know the facial expressions that you see from your students. And that's always an important tool. I know that some students are not comfortable with turning on for various reasons their cameras in their homes, but many of them do if they're just encouraged to do so. All right. So the other thing that I do is I set an intent to record so that they know that they need to be, on their best foot when they are in class, because we're going to record this for them to be able to view at a later time to review the material if they need to do so, or if they're absent, their classmates can see that material as well, and that they're representing their school during this time. The other thing that I include is a person of the month that is related to the month that we are recognizing, from Black History Month to Women's History Month to Asian American Pacific Islander Month, and now in Pride Month. I have found a mathematician that fits those parts of our culture and our community that helps bring a little more inclusiveness and diversity and meaningfulness to my students. And so I sometimes just read these out loud to them. Sometimes I give them anecdotal stories about the people that I know better. And I also try to highlight the ones that aren't the most famous. I mean, everybody knows Fibonacci and Pythagoras, but do you really know Martin Wynne-Low? Like, have you really heard of him? And so giving them that ability to see themselves and others, and also see that mathematics crosses many different genders and cultures and races and backgrounds is makes it more meaningful to them. The other thing that I do is I take the previous warm up from that first slide from the day before, and I give them the analysis of their results. And we talk about what strategies they could use to eliminate answers and where they may have strengths and where their pitfalls are. Obviously, here we have a very much of a pitfall day. Students struggle in the beginning with knowing that the h value next to the x moves horizontally left or right, and they kind of grasp it by the time we're done with polynomials. But when we enter into rational functions, because of that fraction bar, that whole plus minus thing throws them for a loop again, and they don't always remember that the plus would go left and the minus would go right because of the minus being inherently inside of the formula as it's written for rational functions. So we have to keep hammering away at that. Then I would get into my I do part of the lesson. So this is where I'm going to teach, and I'm not doing as much interactivity as I normally would, just to keep the length of this lesson down to 10 minutes. But I'll give you an idea of like how I present the material to my students. Just know that they would be interspersed with questions about details and topics and related things and vocabulary that they may already know when we're experiencing something we don't know, so that I can tie those connections into this lesson. So students, today what we're going to be learning about is how to solve radical equations. And when we talk about radical equations, most of you look at a radical equation and think, oh, this is a square root symbol. And you're not wrong, but you're not entirely right. Generically speaking, it's actually called a radical sign because it can represent any root, not just a square root. It can represent cube roots, fourth roots, fifth roots. What makes that difference is the number that we put right here. And that number that we put right there, we call the index. If you see that that number is the number 3, then that's going to mean that you do have a cube root and you break it down to 3 equal factors. But if there's no number written there, then we understand that that number is understood to be the number 2, which is why often people just call it the square root sign, because by itself, the radical sign doesn't have a number on the index. And the assumed number that would be on the index is going to be the 2. So it's okay to assume that that's a 2 when there's nothing written there, but please call it the radical sign when it's used generically. Only call it the square root of something when you know you're really taking the square root. Now, what's inside of the radical sign is called our radicand. And so what we're trying to do today is we're trying to free that blue part. Free that blue part from the radical sign so that we can find answers to these problems. And we want to find those answers both algebraically and graphically, but we also want to know when those answers actually work. And so one of the things that we're going to look at today is that the radical function does have a definite starting point each time we graph it. And this is the parent version of the radical function. And then it curves off and it continues going in one direction. And that curve keeps getting larger and larger and larger, never comes back down. One of the things that we want to do today is that when we find the solution, or what we think is the solution to the problem, we want to check those solutions. And we're going to check those solutions in 3 different ways. Algebraically, we're going to do it with a scientific calculator to back that up as well as graphically on Desmos. And you know that we've been using Desmos for most of the year, so getting to those websites should not be much trouble at all. So you do want to pull up the scientific calculator for Desmos and the graphing calculator for Desmos onto your screens before I get to the first example. The other part that you want to look at today is that if that answer does not work, we call that answer extraneous. Remember, we talked about extraneous solutions in rational functions as well. And so what that meant in rational functions is that answer ended up causing a division by 0. It didn't work. It didn't solve or balance the equation correctly. Well, we're looking for similar things here, that when you plug your numbers back in, we're not looking for where it'll cause a 0 to be used in division. We're looking for where the left and the right-hand side of the equation are not balanced again, much like you do in your multi-step equations at the very beginning of Algebra 1. Okay, so looking at example 1, I'm going to do this example first, and then I want you to follow along, take good notes, make a little star or note next to the line that maybe you got confused in a step that I explained, so that at the end, we can talk about that and see if you need any help with it. So at this point, what we can do is look at this square root of x plus 6, the radical that's in this problem. And it's just one radical in there. When there's just one radical, we have to do 2 things. We first have to isolate the radical on one side of the equation. And 2, we raise both sides to the power of the index number on the radical. It sounds complicated. It really isn't. What I would suggest, if it confuses you to have all this radical stuff going on, is to write a simpler version of this equation like you would see in Algebra 1 and re-examine it. So like 3 is times that radical. But instead of the radical, I'm going to use like the letter a for the variable. Then that's going to represent all the square root of x plus 6. So 3 times the a plus the 5 that's on the outside equal to the 14. Well, just like we would do in Algebra 1 with a 2-step equation, we want to get a by itself. So we'd have to reverse our order of operations and do inverse operations. Between the multiplication of the 3 and the addition of 5, 5 is the lower. So I know that my inverse of adding 5 is a negative 5, and I'm going to subtract that from both sides because the property of equality tells me that that will keep the equation balanced. These additive inverses, 5 and negative 5, will simplify and leave us just with the 3 times the square root of x plus 6, nothing added, equal to the 14 minus 5 is 9. Now that the addition has been taken care of, we'll have to do the inverse of the multiplication, so we'll use division on both sides. We'll divide by the 3 to cancel the multiplication by 3, so it simplifies to a 1. And then divide by 3 over here to keep, again, the equation balanced by the property of equality. So that means I now have the square root of the sum of x and 6 equal to 3. What we have done at that point is what number 1 tells us in our steps. We have isolated the radical on one side of the equation. All of the rest of the equation is on the second side, the right-hand side. At this point, it tells us that we need to raise both sides to the power of the index. Raise both sides to the power of the index. Well, as I stated earlier, if there is no number on the index, it's understood to be a square root. So that's the power we need to raise both sides to. I'm going to raise this side to the second power. I'm going to raise this side to the second power. Now 3 squared is just 3 times 3, which is 9. But a square root will cancel a square power and leave you with just the radicand, the x plus 6. And that's where we're headed, trying to get this radicand by itself without any symbols on it. Now it's just a basic algebra 1 equation, 1 or 2 steps at most. Minus 6 from both sides. And what we'll see here is that x will equal 3. In order to know if that answer works, we're going to have to check that answer. And the way that we could check that answer algebraically is to go back to the original equation, and in the place of the x, we put the value that we found, the 3. And then we evaluate by our order of operations. And this is the way that I want most of you to do this if you feel comfortable doing your order of operations by hand. And then 3 plus 6 will give us 9, because we know that we take care of the grouping, and the radical sign is grouping the 3 and the 6 together first. Then we take care of exponents and radicals second, so the square root of 9 is 3. Then we take care of our multiplication, so that'll give us 9 plus 5. And then we take care of our addition, so we see that 14 equals 14. And just like we have known since Algebra 1, if these two sides balance, then this is a valid solution. Now, let's say that you have a little trouble with computation, that you're having trouble with making those steps without making an error. It's okay to use a scientific calculator as a backup method, just to make sure, even if you think you're good with your steps, to make sure. So when you pull up your Desmos scientific calculator, what you want to do is type in the same thing that we did over here in green, filling in with that red 3 where the x value is. So I'm going to type 3 square root of the 3 we filled in, substituted, plus 6, and then you've got to do one of two things. You either have to tap right on your keyboard or soft keyboard to come out of that radical sign, which I'm going to do like that. Or if it was over here and you didn't want to tap right, you have to click with your cursor outside of that radical sign, so that when you put the plus 5, it's not inside of it, just like it wasn't inside of it over here. And if you notice, that equals 14. And as we've done previously, if you want to take a snapshot with your snipping tool on your computer and insert that into your Scratchwork that you'll turn into me, that would validate how you did your solution check to make sure that it actually was a valid answer. So either algebraically you could validate it, or you could do it with a scientific calculator. But there's a third way, and we probably haven't thought about this in a long time. We have solved systems of equations for where they intersect each other. And where they intersect, we know that their answers are our solution. Well, if you go back to this and you rethink this from a different angle, you can realize that you can write both sides of an equation as their own equation. So this could be our y equals 3 times the square root of the sum of x and 6 plus 5. And this one over here could be y equal to 14. Just by separating the two expressions into their own equations, we're using a system of equations. And we can solve that graphically if we go to our Desmos graphing calculator and carefully type that in as well. Where these two intersect should be our solution. And it's another way to check your answers as well as solve for your answer. So I'm going to type in y equals 3, the square root of the x plus 6. Now, be careful, again, you need to tap right or either click on the outside of the radical sign before you put the plus 5. That will give you, you see the curve that starts right here and goes outwards. But then we need to put in our second equation, which is y equals 14. And recall, and we did linear equations, and even with the horizontal asymptotes in the last unit for rational equations, the y equals 14 is a horizontal line. And you can see that that does cross over the curved radical. Now I'm going to make this full screen so you can see it more clearly and hide my keyboard. But where those two connect should be the answer. And if I click on that in Desmos, it tells me the location of that intersection point. And sure enough, the x value was the 3 that we found for the x algebraically. And if it's filled in, its coordinating y value is the sum that equaled on the right-hand side for 14. So when we fill in 3, we get 14. It's another way to check to see if the answer actually works. And again, you can snip this graphic to show me that you can use your graphing tool to find the answer and or to check the answer in addition to doing the algebra, unless it specifically says, show me your written steps. All right, so guys, that pretty much wraps up the first problem that I want to do for you. What I want you to do at this point is let me know if there's any questions you may have before we go into one that I want you to help me with. All right, at this point in the lesson, what I would do with students, and I was going to go back to my notes here to make sure I cover all the things that the lesson should cover, is that I've explained to them the I do part so that they can do algebraically the solution. They can use graphing calculator to find the solution, and they can also back up their answers algebraically with a scientific calculator or with a graphing calculator. I would ask them for questions and answer them as they need clarification. And then what I would do is I would go on to an additional example that I would ask them to do together. And I would start soliciting, what's our first step that we do? What's our second step? What would you do here? Why would you make that choice? Why does that work? Those kinds of questions. And then what I would want to do is give them a survey. And that survey would be another way to kind of formatively get some data from that. I want them to give me the 100% emoji in the chat, or I want to give them the surprise emoji in the chat. 100% means I got this. I understand exactly everything you did. And then the surprise emoji says, oh, dude, you messed up something. I need some help here. And so what I want to use that to do is to be able to know, do I need to do another example with them because the majority of them are confused, or are we more on the 100% side of things so I can move on into the next part that I want them to do with each other? And that would be, I want them to make a choice. Which example do you like better? And either give me a thumbs up or a heart in the chat, kind of formatively see, like, where are my students? Because if they go with the thumbs up, I know that they're kind of like on the I get it, but they're on the proficient, maybe not proficient range. If most of them are in the heart range, that means they're challenging themselves, they're advanced, they're getting this, they're ready to make the leap to cubic, cubing each side of it, because we haven't even talked directly about the cube root yet. And so at this point, based on whether they want example A or example B, it doesn't matter to me. It just gives me the feedback to know how well my students are understanding at this point. And I don't even care how they're grouped at this point, because I think mixing the groups up actually helps them to become better regardless of their level. And so what I want them to do is I'm going to put them into breakout rooms randomly. And if they have the same example, great. If they have different examples, great. It doesn't matter. I want them to work out the examples they have, look at each other's work, compare and contrast, swap the different examples and see if they can work it out the way their partner did. If they can explain to their partner how they're doing it, give them 7 minutes, come back and discuss it as a group. See what they figured out, see what questions they still have remaining, see what they feel about this situation. Then at that point, what I want them to do is to show me what they know about how to solve radical equations with the algebra, solving it with graphing, and how to check their solutions. So I'd have them log into Edulastic and take the 3-question lesson check. They'll have about 10 minutes to do that before we discuss it as a group. Now, Edulastic gives me real feedback in real time, so I would know where the most missed question was. And what I would want to do at that point is come back and go over the results, seeing like what was the most missed question and addressing those concerns the students may have about that as a group. Then, based on those results, I would say to them, hey, if you get a 0 or 1 from the lesson check, I want them to stay with me for our one-on-one time at the end of class, and let me give them an extra example or two or a little bit more feedback, go back over this graphing calculator and the scientific calculator piece, and then let them start their Math Excel. What they would not know is that Math Excel has been modified because I know those students are struggling. And then if they got a 2 or a 3 from the lesson check, then I want them to go ahead and immediately start their Math Excel while I'm working with a smaller group of students so they can go ahead and show their proficiency and or challenge themselves. And if anybody finished early, I would want them to go back to their learning management system, which for us is Teams, and look for their assignments so that either they have fallen behind on and need to make up, or if they've got everything caught up and they're really advanced, to do extra credit. I mean, you could call it enrichment, but if you call it enrichment, they see it as extra work. You do extra credit, they're all for it. And that's where I would go with that part of the lesson. And in terms of differentiating for the students, and let me finish sharing the screen here for a second, so there's nothing to look at. What I would want them to do for differentiation is I would, look back over the Math Excel that they're going to do on their own. And they can do that for proficiency. And so therefore, if their proficiency level isn't at least a 70%, then I know that I need to do some remediation or some more one-on-one work with them. If it's above 70%, they're probably ready to go ahead and take their assessment on that lesson or that unit. And what I'd also want to do is that based upon the feedback from the 3-question lesson check that I would have in forms, is that would give me the ability to know, do I hand them the modified Math Excel assignment or do I hand them the full Math Excel assignment? In relationship to the proficient students who have IEPs, one of them has reading comprehension issues, 2 of them have math calculation issues. I would want to address that by allowing the math calculation students, they would already have an existing understanding from our previous work together, that if they use the calculator to do some of their calculations, that's legitimately okay. They just need to give me screenshots of that in their work, whereas the students with the traditional understanding with no accommodations would then make sure that they do their handwritten solutions and their handwritten checks for those. And also that if they have math calculation problems, they could use the graphical version as well to show me that they're understanding how to find those solutions and to be able to explain those to me. And the same thing would go for the non-proficient students who have the reading comprehension and math calculation issues. They would be given the same accommodations as well, so that they could use those graphing devices and scientific calculator devices to their advantage. And then in terms of the reading comprehension for either level, I would either offer less problems that have intense reading, because a lot of Math Excel has very text-driven problems, and there is a way you can select which ones are less text-heavy, or just simplify the directions for any assignment so that they are less wordy. One of the things I like to do in the lessons, if I have a longer time than the 10 minutes I had to share with you, is to also be able to say, hey, that radical sign, which is the same thing as, or, when we do the inverse here, that means we're just undoing it. So a lot of times that reading comprehension piece and that vocabulary piece is a matter of equating it to simpler phrases and statements that they will see as equivalent, and they'll take notes on it, and they'll write down the things that you say to be able to accommodate that. The things that I used for this lesson were Microsoft Forms, Desmos Scientific Calculator and Desmos Graphing Calculator, Wikipedia for my person of the day, Edulastic, and Math Excel from our Envision Algebra 2 text. Now, these are all things that are in our learning management system and options for Dorchester District 2, but I am sure that Cyber Academy has equivalent things for their learning management system and things that we can assess students with. So any of these things could easily be adapted for that. And I hope that gives you a little bit of an information about how I would teach my lesson. Thank you.